Analytic geometry, general and standard equation of an ellipse. Last time I introduced to you the standard equation of an ellipse. I will now go to the general equation of an ellipse. The general equation is given by this: a times x squared plus c times y squared plus d times x plus e times y plus f is equal to 0, where a times c is greater than 0. And that can happen only in two ways. A and c are both positive, or a and c are both negative. Now, if your equation is given in general form, okay, it's not too helpful when we have to identify the center, when we have to visualize, okay, the orientation of the principal axis, which is why the usual thing to do here is to write this in standard form. And we have two standard equations for an ellipse. One where the principal axis is horizontal, and one where the principal axis is vertical. So these are the two standard equations of an ellipse. Here, a squared is always bigger than or larger than b squared. And when a squared appears under x, that means your principal axis is horizontal. Okay? This is your principal axis. If your a squared, okay, the larger denominator appears under y, that means your principal axis is vertical. We have done exercises that are similar to this. How to write a general equation to standard form, which requires a lot of skills in completing the square. So this one is an equation of an ellipse in general form. Okay, so pay attention to the coefficients of x squared and y squared. 1 times 3 is 3, so that is positive. So the skill to use here is completing the square. So we transpose the constant term. We divide the coefficient of x by 2, which is 8 or negative 8, and then we square it. Okay? And then, of course, we must add it to your constant term. This now is the square of a binomial. That is the square of x minus 8. And negative 4 plus 64 is 60. Now, the constant term to the right must be equal to 1. So what we do is we divide this by 60. Okay? So we divide common factors. 3 divided by 60 is 1 over 20. So our standard equation is this one. Now identify the following. The principal axis. So this one, the larger denominator appears under x. So the principal axis is horizontal. And it passes through the center. Okay? And so the center here is 8, 0. So the principal axis is the line y is equal to 0. How about the center? The center is 8, 0. How about the length of the major axis? So the major axis would be the line segment that connects the two vertices of your ellipse. Okay, what is the length? Well, A will help you get the length. A here is equal to the square root of 60, and that is equal to the square root of 4 times 15. So that is equal to 2 times square root of 50. So the length of the major axis is 2 times square root of 15. That is 4 times square root of 50. The length of the minor axis, okay, so that is the line segment, that is a chord, vertical, that is perpendicular to your major axis and passes through the center. So B will help us find the length of the minor axis. It's equal to 2 times B. And B here is equal to square root of 20, and that is just 2 times square root of 5. And so the length of the minor axis is 2 times 2 times square root of 5, and that is 4 times square root of 5. Let us write this in standard form. So we transpose the constant term, and then pay attention to this. We will factor out 6, okay, because we want x squared to have a coefficient that is equal to 1. So we will factor out we will factor out 6 and 10, okay, the same with y squared. We want y squared to have a coefficient of 1. So I'm going straight to completing the square here, okay? So after factoring out 6 from these two terms, it becomes something like this: x squared plus 6x. You divide 6 by 2, you square it. Here, you factor out 10 from 10y squared minus 20y. And so it becomes 10 times this. Now, again, completing the square, negative 2 divided by 2 is negative 1. And then you will square it, okay? You will square it. I'm sorry. So this requires another closing parenthesis. Okay, so negative 4 plus. Okay, so you squared 3, that's 9. But 9 times 6, look at that. 9 times 6 is 54. Okay, so you will add 54 to your constant term. And then, look at this. This is negative 1 times 10. No, this is not negative 1. This is 1 squared. Negative 1 squared. So that's 1. 1 times 10 is 10. So you will also add 10 here. So we can now write this as 6 times the square of x plus 3 plus 10 times the square of y minus 1. And this one, okay, this is 50 plus 10 is 60. We divide our equation by 60 because the constant term here must be equal to 1. So this is the result, okay? So 6 divided by 60 is 1 over 10. And 10 divided by 60 is 1 over 6. So our equation is now in standard form. Identify the following. What is the principal axis? Pay attention to the larger denominator. It's 10. It's below x. So the principal axis here is again horizontal. And our ellipse, the orientation of our ellipse is horizontal. The principal axis passes through the center. Okay, so it's going to be y is equal to 1. The center is negative 3, 1. The length of the major axis is 2 times a. The major axis is the line segment that connects the vertices of your ellipse. Okay? It's 2 times a. But a is equal to square root of 10. So it is equal to 2 times square root of 10. Get the length of the minor axis. So the minor axis is a chord that is perpendicular to the major axis, okay? And it passes through the center. And the length of that is equal to 2 times b. b is equal to square root of 6. And so the length of the minor axis is 2 times square root of 6.